Hi guys, welcome back to Mathematics for Engineering 3 for students at Kasetsart University. Uh, this is the last video for chapter 1, so that's the good news, okay? In this video, we are going to be looking at a method which is called a substitution suggested by, equations, okay? And this method is the last one is the one that if you check some other methods and they don't work, okay, they don't really work, so this is the last method that you should use. Okay, so first you should go through all the previous methods, separable, homogeneous, equation with linear coefficients, right? Exact equation, integrating factors, and blah blah blah, right? Linear equation, Bernoulli, Riccati, and those methods that we have, right? And if all don't work, then you try this method, okay? And it's I think I'm not saying that it's harder than the others, but it's a lot trickier, okay? It's a lot harder to see and to solve. It's pretty much the same as the observation method, okay? So let's start, okay? We have been looking at the form mx plus ny equals 0, right? We have been looking at this form, which is the first order differential equation, and we have 8, right? We have 8 forms, 8 methods, like many of them if you go back, from separable, from homogeneous, when the coefficients are linear equations, we have exact equations, we have many of them, right? Bernoulli, Riccati, and the linear equation, integrating factors. We have many of those methods, but once you see the equation, the ODE, and then it doesn't fit any methods mentioned earlier, okay? If the equation that you see, it doesn't fit any methods, so it seems like you can't use any methods mentioned earlier to solve that problem. It may be possible that by some change of variables, okay, by doing some substitution, you can transform that problem to the one that we already know how to solve. Okay, so first we see the problem that doesn't fit any method in the previous sections, and then we will be trying to look at the right substitution. Okay, what substitution is the right substitution? And once we do the substitution, the equation here becomes the one that we know how to solve. Okay, so I have a note here. A note here is that is useful, but it's not 100% work. Okay, it won't work 100%. But the trick is just that it's from the observation. So what you need to substitute, just substitute what you see many times. What you see many times in the equation. Substitute what you see many times in the equation. Okay, but that is not 100% rule, okay? It won't work at all times. Okay, so it works sometimes, so but it's a good trick, okay, if you don't know where to begin with, so it's a good start. Okay, so let's look at this example. If you look here, this one, actually I know that it's the coefficients are linear equations, right? Actually this one actually we know how to solve it, right? Is linear uh coefficient, right? It's linear coefficients. So you look at a1, b2, a2, b1, right, and see if they are equal, whether or not we have only one solution, right? If we have only one solution, blah blah blah. If we have, no solution, or infinite number of solution, is blah blah blah, right? We have two cases, if you remember. But okay, let's assume that we don't know. Let's assume that we don't know. We don't know that it's a linear coefficients. Okay, we don't know there's linear coefficients, but we want to solve it. So what would we do? What we would do is that I would look at this term. Okay, and they look very similar, right? They look pretty much the same. So what I do is that, guys, again, you can solve this equation by linear coefficients technique, okay? But I just assume that I don't know that technique, okay? So I'm gonna do some substitution, okay? So I let v be x plus 2y. So dv is actually dx plus 2 dy, okay? And then I substitute that into this equation, and what I have is is v minus 1. dv is actually dx is actually dv minus 2 dy, and then plus 3 v dy equals 0, okay? And that would be v minus 1 dv minus plus 2 plus v minus 1 times minus 2 dy plus 3v dy equals 0, and that would be v minus 1 dv plus is minus 2v plus 2 dy plus 3v dy equals 0, right? Let me check if it's correct. It's minus 2v plus 2. Okay, so here is v minus 1 dy plus v plus 2 dy equals 0. Okay, and then we know that this is actually this is the dv. So we know that it's v minus 1 dv divided by v plus 2 plus dy equals 0, and this is the separable. And guys, if you solve this by linear equation, linear coefficients, you know that a1 is 1, b1 is 2, and a2 is 3, and b2 is 6. So a1 b2 would be 1 times 6, which is 6, and a2 b1 would be 3 times 2, which is 6. So they are equal. It means that they are infinite solutions, right? In that case, we will do the substitution, right? And we get the separable equation as well. So what I am trying to tell you is that a linear coefficient, when we have infinite solution, is pretty much the same as this method. Okay, it is subset of this method. Okay, it can be seen as the substitution suggested by equations. Okay, okay, so both are the same in this case. Okay, and then if you follow the steps that we use in the linear coefficients technique, you're gonna end up with the same separable equation. So to solve that, I will just integrate this equation, and I can see here, and integrate of dy is y. That's easy, just do it first. Okay, and then we want to find integrate of v minus 1 divided by v plus 2 dv, which is integrate of v plus 2 minus 3 dv divided by v plus 2. Makes sense? Because v plus 2 minus 3 is v minus 1, isn't it? Isn't it? Right? Because, because 2 minus 3 is actually minus 1. Okay? I think we've seen this technique many times already. So you should be, really familiar with it. And then if v plus 2 divided by v plus 2 dv minus integrate 3 divided by v plus 2 dv. And that would be, what is it? V minus 3 log of v plus 2. Okay? So the solution would be v minus 3 log of v plus 2 plus y equals c. And then if you substitute v in there, you would get, what is it? V is actually x plus 2y, right? So you have x plus 2y minus 3 log of x plus 2y plus 2 plus y equals c. And that is the solution. Okay? So here, this equation is actually the equation with linear coefficients. So it can go back to the method that we know. But if we assume that we don't know this method, we can substitute v by this x plus 2y, which appears a couple of times in the equation. And then it's exactly the same thing as the technique in linear coefficients case suggests us to do. It's the same approach. Okay, so you just pick one of them. If I were you guys, I would use this one. I won't use this one for this equation. Okay, cool. Okay, let's look at another example. This one is a bit more tricky. Okay, I don't know, I don't think it's separable. At least from what I see here, it's not separable. And it's not, you can check whether or not it's homogeneous. I don't think it is. And if it exact, if it is the assume that this is not any of those. Okay, assume that it's not any of those. Not that I can see. Okay, so to solve this one, you if you notice, if you let u be 3y minus x, you will see that this guy is actually e to the u, right? It's e to the u. Okay, and then dy, right? Sorry, dx will be just, what is it? Du minus 3dy, right? And this 3dy will be cancelled out from this dx. See? So maybe substituting 3y minus x with u might be a good idea. It might be a good idea. Look at it again. If I let this guy be u, okay, I let it be u. So du is 3dy minus dx, right? So dx is du minus 3dy. So if I substitute dx in there, right? If I substitute dx in there, sorry, it would be no. is the 3 dy minus du. So if I substitute the x in there, this the 3 dy might be cancelled out. Okay, so let's have a look if it's really true. So du is 3 dy minus dx. Okay, so dx is du minus 3 dy. Okay, so in that case, we have that is 3 plus 8y cubed e to the u dy minus du minus 3 dy equals 0. Okay, and this I have this parenthesis, and then it's 3 dy plus 8y cubed e to the u dy minus du plus 3 dy. Okay. Oops, guys, sorry. I did this mistake. I made this mistake twice. Come on, sorry, guys. Here is 3 dy minus du. Okay, so here I change it to 3 dy minus du. Okay, so it would be minus 3 dy plus du equals 0. And guys, this got cancelled out. Okay, so we have 8y cubed e to the u dy plus du equals 0. Okay, and then you see is it separable, right? Why? How? Because if I divide the whole equation by e to the u, what I would get is 8y cubed dy plus e to the minus u du equals 0. Right? I multiply the whole equation. I divide the whole equation by e to the u. Or in other words, I multiply the whole equation by e to the minus u. Okay? And then this is separable. So I integrate. So I get 8y to the power of 4 divided by 4 plus it will be integrate e to the u. Okay, so before I integrate, can I do this first? Minus of integrate e to the minus u d minus u equals 0. Okay, guys, don't forget d of minus u, this one, is actually minus of du. Okay, so if you have minus of du, you have another minus here, you recover du. Okay, this minus here and minus here cancel out, so you get the same problem. Okay, so let's integrate it. I would have 8y to the 4 divided by 4 minus e to the minus u equals 0. Okay, and then I substitute back, I would get, my bad, this must be c. Okay, and this is c as well, sorry. You know, after integrate you get a constant, right? So here you substitute back, you get 8y to the 4 and the 8 cancel out, so you get 2y to the 4 minus e to the minus u, which is 3y minus x equals c. Okay, so the solution, can I write it here? The solution would be 2y to the 4 minus e to the x minus 3y equals c, and that's it. See, but the tricky part is here, is to see that if you let u be 3y minus x, you would get a separable equation. and that's tricky. And how do I know that? How do you know that? You need to do lots of exercises, okay, and then you see that what is the right substitution. Okay, cool. Let's look at another example. Okay, for this example, you can see, right, as I told you, you see 10x here once, you see here twice. So maybe it's worthwhile to substitute u by 10x, okay? But I don't see that yet. Okay? So let's before doing that, let's try to see it first. Okay, let's try to see it first. So guys, if you look here, you have y, you have one y here, right? And you have another one y here, right? How about I divide the whole equation by y? So what I would have 10x dy divided by y, right? Minus 4 log y minus y 10, sorry, minus 10 cubed sec squared x dx. Okay, and then guys, if you substitute 10 by some u, okay, you substitute that 10 by some u. Okay, so if you let u be 10x, of course du would be sec squared x dx, which is exactly that guy. Okay, so let's do that first and see what happens. Okay, so you could, right now I don't know yet as well, so just do that first, because it looks really tempting, right? It looks that it should be right, because you have sec square x as well. So if I let u be 10x, so what I have is u divided by y dy minus 4 log y minus u cubed, and this is du, right? Because du is sec squared x dx. Okay, so you get du, and that is it equals 0. Okay, and after that, here, as you can see, it's not separable, is it? No, it's not separable. It's not, it's not homogeneous. As you can see, it's clear that it's not homogeneous. And this guy is homogeneous, but this guy is not homogeneous, right? So I don't know, it's not linear, it's not Bernoulli, it's not Riccati, it's not Blab, it's not all of them, right? So what should we do next? How about guys, look here, you have log y and you have 1 over y here. That's really tempting as well, right? So if you let v be log y, so you have that dv is 1 over y dy, which is exactly this guy, right? So it seems like you can write this equation in the form that is u dv minus v, for v minus u cubed du equals 0, and that will be the form. Okay, and then it's still not separable, it's not homogeneous, but guys, if I look at it this way, I look at dv. What is dv? would be minus of what? Minus of 4. Okay, let's me distribute it, this guy first. V dv minus 4v minus plus u 4v du plus u cubed du equals 0. Okay. Okay. Oops. Guy, sorry. it's another mistake. Here is u, it's not v. Right? Right? Because you have u here. Sorry. Okay? So in that case, if I divide the whole thing by u, this is all I would get. It would be dv minus 4 over u v du equals minus u squared du, right? And as you can see, if you look at v as y, and this is y, dx, x, and that is linear, right? That is linear in terms of u, right? Because this linear when v is a dependent variable. So this guy is x, in the terms that if you look at v as y and u as x, right? They will be just function of x, function of x, function of x. You have one y here, right? And you have dy here, and that is actually linear equation. Okay, so if it's linear, you can introduce an integrating factor. Okay, my integrating factor would be mu equals, and it's gonna be this guy, right? If you remember, right? It's gonna be this guy, right? It's a coefficient of v, right? It's the coefficient of the second term. So v would be e to the integrate minus 4 over u du. Okay, and that would be e to the minus 4 log absolute u. Okay, and that would be e to the log of absolute u to the minus 4. Okay, and that is absolute u to the minus 4, because as I told you, this guy cancel out. But guys, absolute u to the power of minus 4, this guy is actually 1 over absolute u to the 4, right? But if it's to the 4, it's always positive, so I can remove the absolute. Okay, so I get u to the minus 4. And again, the mu would be e to the minus integrate 4 u du minus 4 over u du, which is mu times minus 4 over u du. Okay, that will be the integrating factor. Okay, so I'll look at, I'll let this equation be star. Okay, then I'll move this equation to the next page. And then I'll move the integrating factor as well. I'll move all of them. Just put it here. Okay, so I'll just delete what is, not necessary. I'll delete this. So I know that mu is actually u to the minus 4, and d mu is actually this guy. Okay, I'll keep it like that. So here guys, I'll multiply mu to this star. So what I have is mu dv minus mu 4 over u v du equals minus mu u squared du. Okay, and guys, again, as we did many times, mu, this guy is actually d mu. Okay, and this is here, this guy and this guy. Okay, so here is mu dv minus v d mu equals minus mu u squared du, and that would be d of mu v equals minus mu u squared du. But mu is u to the power of minus 4. So what we have is d of u to the minus 4v equals minus u to the minus 4 u to the 2 du. And then it's d of u to the minus 4v equals minus of u to the minus 2 du. And then we integrate. Let's see. Okay, so this cancel out. So we have v divided by u to the 4 equals, so how to integrate this function? It will be minus of u to the minus 1 divided by minus 1, right? You plus the exponent by 1 and then you divide it by the exponent. So this is a simple integration. So here in plus c, so we have that is v divided by u to the 4 equals 1 over u plus c. Okay, but as we know that u is tan x and v is log y, so we have that is log y divided by tan 4x equals 1 over tan x plus c. Okay, and that is the solution. Okay, if you want to make it look a little nicer, you can multiply the whole equation by tan to the 4. So you get log y equals tan cubed x plus c tan to the 4x. That would be a little bit nicer. Okay, guys, you do this question as an exercise. Okay, you do this question as an exercise. Okay, so that's it for the the substitution suggested by equations, and that's it for the first chapter. Okay, so guys, do lots of exercises. Okay, that would help you. Okay, I know some of them is not trivial. Okay, it's not trivial at all. It's not obvious. So you need to practice a lot. Okay, in order to understand, and to understanding is not enough. I understand that many of you understand what is going on in the lecture, but to be able to do it yourself is another story. Okay, so you need to try to do exercises, okay, so that you can do it yourself. Okay, not only that you understand it, but you need to be able to do it yourself as well. Okay guys, so bye for now and keep fighting. Okay, at least we halfway to the midterm. Okay, so see you in the next video. Bye bye.